Hello, this is Mr. Huber. In this lesson, we're going to learn more about linear equations and using and writing slope-intercept form. So you're going to recall, slope-intercept form is called that because it uses the slope, the m, and the y-intercept, which is the b. So our y equals mx plus b. To have slope-intercept form, we need the slope and we need the y-intercept. If they're not given, we might have to find them. So the first thing would be, do I know the slope? If I do, great. If not, calculate that. Do I know the y-intercept? If I do, great. If not, I need to find out what it is. So we're going to see examples now where we have to find a slope, a y-intercept, and use them to write that slope-intercept form of the equation of the line. So in this first problem, we've got a line with a slope of 2, and it passes through the point 6, 3. So we've got a slope. We don't have a y-intercept. We've seen before maybe we have a y-intercept given to us. We'd have to have an x value of 0 to have this be the y-intercept. So the y-intercept here is not 3. We're going to have to find out what it is. So how can we do that? Well, we can use y equals mx plus b and plug in our x, our y, and our m. So we're going to have 3 equals 2 times 6 plus b. We have a y equals mx plus b. We plug in everything we know except the b that we're going to solve for. Now we can solve for this. We do 3 equals 12 plus b. 2 times 6 would be the 12. I subtract 12. On both sides I get negative 9 equals b. So now I have my m and I have my b. And I can write my equation y equals 2x minus 9. That would be the equation of the line with a slope of 2 that goes through the point 6, 3. So we use what we do have and we solve for the piece that we don't know, the y-intercept. In this second problem here, we've got 2 points, so we don't have a slope either. So we need to start with that. Okay, if we don't have a slope, that's where we should start. So our slope is going to be y2 minus y1 over x2 minus x1. So 3 minus negative 3, that's 3 plus 3, which would be 6, over 5 minus negative 5, excuse me, minus negative 2, so negative 5 plus 2, which is negative 3. That's a slope of negative 2. 6 over negative 3 would be negative 2. Now I've got a slope, and I can use either point I want. It does not matter if we use this x and y or we use this x and y. You can pick either one you want. I'm just going to take the first one here, but it doesn't matter. You can use either one you want and write the y equals mx plus b using the x, the y, and the m and solving for the b. So here we're going to have negative 3 equals negative 2 times negative 2 plus b. Right? I took my y. Negative 3 is my y, equals m. M is negative 2, x is negative 2, plus b. I've got my y equals mx plus b where I use the x and the y. Right? From this coordinate, make sure you plug the x in for x and the y in for y. I got my slope that I calculated, and now I can find the y-intercept. So I can simplify this. Negative 3 equals 4 plus b. Subtract 4 on both sides. Negative 7 equals b. So my equation now is y equals negative 2x minus 7. That would be my equation for that line that goes through those 2 points. So I calculate the slope if I don't know it. Then from there, I can find the y-intercept, and I've got my slope and y-intercept. I can use them to write the equation of the line, y equals mx plus b. Find the m, find the b, put them into your equation. Let's try another one like that. And again, you should be trying this. Let's see what you can do to come up with an equation of the line through the points negative 2, 5 and 2, negative 1. So we're going to start by calculating the slope because we don't have that. So we start off by doing m equals negative 1 minus 5 over x minus x, 2 minus negative 2. Okay, that's negative 6 over 4, which I can simplify to negative 3 over 2. So my slope would be negative 3 over 2. And now I can calculate using either point. Okay, I'm going to use the second point this time just so we can see it doesn't matter. I'm going to use this second point here. Doesn't matter which one you use. You will get the same y-intercept if you do things correctly. So I'm going to do negative 1 equals negative 3 over 2 times x plus b. And I can simplify that. Negative 1 equals negative 3 over 2 times 2. That's like 2 over 1. So this would reduce to 1 and 1 and be negative 3 plus b. And then I can add 3 to both sides. And I get negative 1 plus 3 is 2 equals b. So I can write my equation, y equals negative 3 over 2x plus 2. Right? Again, when I use my y equals mx plus b, if my slope's a fraction, that's fine. We have whatever that m is times the x. We have to be able to work with those fractions there to solve for b, and then I've got what I need to write my equation, the slope and the y-intercept. Now let's see one written as a function. Okay, so function values. F of -4 equals 3. So we need to know how to write that. That's really a point, right? -4, comma 3. F of 6 equals -2. That means when I have an x value of 6, my output, my y value, would be -2. So now it's like it was in the last couple problems. So I can calculate a slope. Make sure you understand function notation and what that information is that you're being given there and when it's written in function notation. So my slope is going to be -2 minus 3 over 6 minus -4. That's -5 over 10, so -1/2 for the slope. And again, you can pick either point you want. It doesn't matter here. I'm going to take the first one, so I'm going to have not -3, 3 equals -1/2 times -4 plus b. Right? So I use this point. This is my y, m, I just calculated, my x, which is -4, and plus b. Again, I can solve for the b. I've got everything except the b. That means I can solve for it. So I'm going to have 3 equals -1/2 times -4 is a +2 plus b. I subtract 2 on both sides. I'm trying to solve for b. I get 1 equals b. So now I can write the equation of the line. Y equals -1/2 x plus 1. There's my equation of the line. So function notation, understand f of -4 means I'm putting in a -4. That's my input, which is my x value. My output is 3. Input, comma, output. All right? And I can use those 2 points then to calculate a slope and then get the y-intercept. Right? So when we're writing equations in slope-intercept form, we've seen some different situations. Let's just recap them here. Okay? If you're given a slope and y-intercept, relatively straightforward. Just plug them in for the m and the b. Okay? If we have a slope and a point, so if we have a slope and a point, we can use the point as our x and y, our slope as the m, and we can plug them into y equals mx plus b and solve for the b. So when we solve for b, then we can write the equation. When we're given 2 points, we have to calculate the slope and then the y-intercept. So we use the points to find the slope, and then, like we did over here, we did the slope and a point. You can use any point you want. So if you have 2 points, pick one of them. It doesn't matter which one you use. And then you can calculate the b value, and you'll have your slope, and you'll have your y-intercept, and you write the equation. So find the slope if you don't have it. When you have the slope, use a slope and a point to find the y-intercept. Once you have the slope and y-intercept, you've got what you need. Write it in. Put in the slope for the m, the y-intercept for the b. Before we see some more linear equations, let's take a little break, a short stop, if you will. We'll see how short we can make this. Who was the MVP of the World Series last year? The Detroit Tigers won the championship, the MLB World Series. It was a while ago. You can tell from those pictures. Alan Trammell won the 1984 World Series MVP award. The Tigers won the World Series in 1984. You can see this is old Tiger Stadium. Here, I guess he got that car for winning the MVP. Alan Trammell was a great Tiger. He played for them from 1977 to 1996, a long career there with the Tigers. He actually was a manager for a little bit for them as well. He's a 6-time All-Star. Along with winning that World Series MVP, he won the Gold Glove 4 times, and his number 3 is retired by the Tigers and was eventually elected into the Baseball Hall of Fame in 2018. So Alan Trammell, 1984 World Series MVP for the Tigers. All right, let's see another application problem for a linear equation. So we've got a situation here where a gym charges $35 per month after initial membership fee. We don't know what that fee is. A member is paid a total of $250 after 6 months. So we want to look at that like an input and output. Okay, and we're going to write an equation for this. We're going to need a slope and we're going to need the y-intercept. Well, we've got the slope. All right, this is our slope right here per month. That's a rate of change. That's our m. Okay, this is an input-output right here. The 6 months and $250. Right. So this is like having the point 6, comma 250. We put in 6 months. We know we're going to have a total cost output of $250. So we can use this to find the b value, right? The membership fee, the starting amount, that's what a y-intercept is. It's the starting amount. It's the value when the input is 0. So at 0 months, when you haven't paid any monthly fees, you have that initial membership fee. So we're trying to find out when the x is 0, what's the output, right? That's what a intercept is, in this case an initial starting amount. So we can write an equation. We have 250 equals 35 times 6 plus b. That's 250 equals 210 plus b. When I subtract 210 on both sides, I get 40 equals b. So the first part of this question says to write an equation that gives the total cost. So if I want to write an equation for the total cost here, I can have the total cost is equal to 35x plus 40, where x is the number of months. Okay. I avoided using m so we didn't get it confused with slope, but you could use any letter you want, right? So c equals 35x plus 40. That would be our equation that would give us a total cost for 1 month, 8 months, or in this case, we're going to find out what happens after 10 months. So if we want to find the total cost after 10 months, so after 10 months, we'll do that over here. My total cost would be 35 times 10 plus 40. So it's going to be 350 plus 40. It would be $390 for my total cost after 10 months. Okay, so we solved for the starting amount. $40 is the initial membership fee. That's how much we're paying at 0 months, right? If I put 0 months in here, I'm still paying $40 for that initial fee. So when we see these application problems, remember, rate of change, that's our slope. The $35, that's the rate of change. We can use the 250 after 6 months to write an equation and solve for that starting amount. Let's check out one more application of linear equations. So we've got a situation here at a racetrack that charges a membership fee, and we've got an amount that a racer paid, $76 for 3 races, and another racer, $124 for 7 races. So we don't have a slope here. We're going to calculate the entry fee per race. That's our rate of change. We're going to use this input and output, right? $76 is the calculation we get after 3 races. So we're inputting 3 races and we're getting out $76. Then we're inputting 7 races and getting out $124. So these are 2 points we can use to calculate a rate of change, then use that with a point to calculate the y-intercept, and like we did on the last couple problems, write a linear equation using the m and the b. So let's calculate the m first. So our slope, our rate of change, is 124 minus 76 over 7 minus 3. Y minus y over x minus x, that's 48 over 4, which is 12. So the entry fee per race, $12 per race. Okay. Now we want to use one of the points and that rate of change to find the starting amount. So I'm going to use 76 equals 12 times 3 plus b. Y equals mx plus b. It doesn't matter which point we picked. I've used 3 comma 76, but it doesn't really matter. So I have 76 equals 36 plus b. And now when I subtract 36 on both sides, I get 40 equals b. Okay, that's the membership cost, $40. That's our starting amount, right? That's the initial cost. We have to pay $40 even without any races. At 0 races, there's still a cost of $40. Remember, that starting amount is a y-intercept. Think of that y-intercept as a starting amount in these application problems. Think of slope as your rate of change. That's the rate at which the cost is changing, $12 per race. That per usually indicates the rate of change part of what we're looking for. Okay? And now we can write an equation here. The total cost is equal to $12 per race plus $40. So we have an equation, right, for the total cost as a function of the number of races. And we could check it if we wanted. We could see, does this work? So we could put a 3 in here for the number of races. 12 times 3 is 36 plus 40 would give us a total cost of $76, which it should. Right? So keep that in mind. When we see these application problems, the slope is a rate of change, right? Inputs and outputs, we got 2 points here. 3 races as the input, $76 as the output, and 7 and 124. When we have 2 points, we calculate a slope. If we don't know the slope, start there. Once you have the slope and some point that you can use, put those in for the y, the m, the x, and calculate the b, which is that starting amount. Right? To write a linear equation, we need the slope, the m, the y-intercept, the b. Find those 2 things, plug them in, and you've got your equation written in slope-intercept form.